Hello and welcome, dear viewers. Welcome to JE Limitless. Thank you for giving this video a chance, and let's deep dive into cracking IIT via this problem series Think Like JE. Our mission for this series and this channel is to supplement your JE preparation with some unconventional concepts and ideas you probably may not have heard before in your classroom lectures and wherever you go to study for your JEE preparations. Here in this channel, we try to anticipate coming trends in the way JEE is going to happen in the coming years in the future. Uh, the exam seems to be coming back to its pre-COVID levels, means questions that require rote learning are decreasing, and questions that require creative and conceptual thinking, they seem to be on the rise. To solidify my point, let's look at this year's January session paper, especially of mathematics. The questions seem very creative, they seem very thought-provoking, especially in the algebra section, and were clearly inspired by Olympiad concepts. Topics like Euler's Stoichion function, Legendre's formula, recurrence relation, and Fermat's little theorem were asked, just to name a few. And this is expected to happen in JEE Advanced as well. Through this series, we will try to take up such creative questions which probably have not been asked in JEE before, and by following this series, you will be at a huge advantage as compared to your peers. This series is intended for JEE 2026 and 2025 aspirants, so questions will be based on algebra, trigonometry, and coordinate geometry. So without further, for now on, and later on, we will try to include calculus and limits and functions as well. So without further ado, let's begin discussing this problem. It's a question of quadratic expression, and in brute force, this seems kind of doable. Okay, it's not like the question seems unfamiliar, or we may have encountered this question before, but this can be done smartly also, and that will save us a lot of time, which we can use to solve other type of questions in the paper as well. See, that's the thing. JEE means the hype has become that the paper is becoming more and more lengthy. But I think with the right approach, the questions which look very difficult and lengthy can be solved very easily. But you need to know the right concept. It's very difficult to think of them on the spot on that stress of that very important examination. So that is what we are trying to do here, to make you familiarize them with whatever important and new concepts there are, so that they save your time and your energy in the paper. Okay, so let's begin this. I suggest you pause this video and give this question the respect it deserves. Spend at least 10 to 15 minutes on it. If you solve it, then it's very good. And see if one of those, if you are able to match one of these options. Okay, I hope you have attempted this on your own. Okay, let's begin. So f of x is given to me as x square plus bx plus c. So there are two variables here, b and c. They are real numbers. And it is given to me that f of 2 plus t is equal to f of 2 minus t. So method 1, that will be like sheer brute force. Just do whatever the question tells us to do. Put 2 plus t here in that expression. So this will become 2 plus t ka whole square plus b into 2 plus t plus c. Same with this, 2 minus t ka whole square plus b into 2 minus t plus c. Uh, both the sides of the equation will form a quadratic equation. We can compare the coefficients; their ratio will be same, and that way, I guess we get two equations in B and C, and from that we can solve. But I will not even try to attempt this because this is a very lengthy approach. This will take a lot of time. Okay, so I guess it's not worth devoting this much time into a problem that we can very easily solve just by sheer observation using the properties of quadratic expression and the way the numbers are presented here. So let me help you see that. So it is given to me that f of 2 plus t is equal to f of t minus t. And I know that f of x is a quadratic expression. This is known to me already. So the graph will be something like this of this quadratic, right? Since the coefficient of x square is 1, so it will be concave up. The graph will be concave up. Now let's observe what this means. F of 2 plus t and f of 2 minus t. Okay, so let's assume I am at 2 here. If I go t steps ahead, I will reach 2 plus t. And if I go t steps to the left, I will reach 2 minus t. Let me correct this here. So this is just the virtue of the number line. Okay, and they give the same value when we put this into a quadratic. So we go an equal distance from 2 to the left and to the right, and we get the same value. How can we place this into the quadratic here? I guess you saw that very smartly. We can say that the vertex of this graph is 2 only. This was my observation. This was the core part of this problem. Just sheer observation that 2 will be the vertex of this quadratic equation. Just by this quadratic, just by this function, I can say that 2 will be the vertex of this quadratic equation. I don't know anything else, but what I do know is 2 will be the vertex. Let's observe. So let me draw this line here. So I went 2 plus t steps in this way, and I arrive at 2 plus t. I went t steps this way, and I arrived here, which is 2 minus t. And look, they both are same. This is f of 2 minus t, and this is f of 2 plus t, and they are equal. They lie on the same horizontal level, so they will be equal. Hence, our initial assumption is verified as well. Since 2 is the vertex, so the graph will be completely symmetrical out this point. So if I go t steps to the left or to the right, the value of the function will be the same only. I hope that makes it clear. So we can proceed. So vertex of x square plus bx plus c is x square plus bx plus c is 2. The vertex will be given by minus b by 2 into 1, which is 2. So minus b upon 2 will be 2. This gives b is equal to minus 4. All right, so we have accurately determined the value of b for this expression. Okay, so let's come back to the quadratic. F of x was given as x square plus bx plus c. We have found out b, so we will get x square minus 4x plus c. Now you may think about finding c, but I don't think this is required here because given the options, we are just to compare f of 1, f of 2, and f of 4. All right. So already I know that f of 2 will be the smallest. How can I say that? Because 2 is the vertex of the quadratic only. So the minimum of the quadratic will lie at the vertex. So f of 2 will be minimum. That I can definitely say. And by that process, option D and A are eliminated. F of 2 is the lowest only in options B and C. So now we are to compare only options B and C. So let's look at f of 1. F of 1 will be 1 squared minus 4 into 1 plus c, which is 1 minus 4 plus c, which is c minus 3. F of 4 will be 4 squared minus 4 into 4 plus c, which is 16 minus 16 plus c, which is c only. Clearly, we can say that c is greater than c minus 3, right? Because we are reducing something from c, so the value will get decreased. So c minus a will be less than c. This makes f of 4 less than f of 1. So this is the required relationship between f of 4 and f of 1. And by that fact, Option option B comes out to be correct. So my correct answer is option number B. All right. I hope that makes sense. Okay, let's look at a bonus concept for this problem. Okay, we can also compare f of 4 and f of 1 graphically by using the graph. We may not even need the algebraic approach. Okay, so let's begin. F of 2 will be here, 2 will be the vertex of this problem. F of 4, to go to f of 4, I need to climb 2 steps to the right. Okay, so I will be somewhere here. If I climb 2 steps, I will be at f of 4. And if I go 1 step to the left, I will be at f of 1. All right. So obviously I took less steps, so I will be lower, right? So this is f of 1. Since on the left I had to go much more steps, I had to go 2 steps to get to 4, but on the left I had to go only 1 step to get to 1. So obviously the line for f of 4 will be higher than the line for f of 1. So we can say that f of 4 will be greater than f of 1. All right, I hope that made sense. The main idea was to go from the vertex, the you can say the position of equilibrium, stable equilibrium, to the place that we want to explore. So to go to 4, we need to take 2 steps. So obviously we will reach at a higher point, and to go to 1, we need to take only 1 step. So we will be stuck at this lower point only, and by that virtue f of 4 comes out to be greater. So we can compare this graphically as well. So here are the two approaches, algebraic one and graphically, the approach, both will give the same answer. Okay guys, thank you for watching this video. I hope your brain got stimulated and you had much fun solving this problem with me. Okay, follow this channel for everyday improvement. Till then, be happy and have no limits on your dream of an IIT. Thank you.